Yes, thanks, Sharon. Thanks, everybody. It's a pleasure to be here, to be with you. My name is Karl Podesta. I am Irish and I'm based in Dublin, but I work for Microsoft covering the Europe, Middle East, and Africa region. And I work every day with customers doing HPC on Azure. And I'm very excited to be here. I've been with the company 5 years, and every day this is what I do, but my career has been as a Linux HPC engineer. And I'd love, together with our partners AMD here, to show you the easiest, quickest way to do some HPC and supercomputing and get access to these fantastic AMD CPUs. So let's see. So I wanted to keep it simple. I wanted to tell you what Azure is, what Azure HPC, what AMD EPYC CPUs is exactly, why do people do it? Why do people do supercomputing in the cloud, in the public cloud? Who is using it and what they're using it for, and how to do it and how to get started yourself. So to share a bit of the insight that we've learned over the last number of years working with customers doing this kind of work, and give you some ideas for how to get started yourself and try out some HPC in the public cloud. So what exactly is Azure, if you have not heard of it before? Really, Microsoft is a software company, and we have the four pillars here that we have built Azure on top of, and that's in order for you to be future ready about your applications, to allow you to build on your own terms with whatever software environment that you like to build with and code with. We want you to operate seamlessly with on-premise supercomputers, HPC, on the edge, wherever you will be. And we want you to trust us, so to put your data into computing with us. We put a lot of work into making sure that this is the case. Azure is aiming to be the world's computer. So that means all types of computing are welcome, and you'll see for HPC and supercomputing also. A little bit more detail on that. I mean, Azure effectively is not just a data center, it's hundreds of data centers globally. There's 60 individual Azure regions around the world. In each individual region, there are several data centers. So I sit in Dublin, and it's the North Europe region for Azure, and there are at least 10 to 15 individual data centers here in a several kilometer square radius. And that gives you some idea of the scale that Azure is at. In terms of the security investments that we've made, you can see that there are thousands of security professionals working every day, trillions of signals, and a substantial investment that we make in protecting Azure, our customers, and their data. Building a data center is not easy. I know many of you might have done this also, but gaining compliance in order then to put your data from different individuals, governments, certifications are available. We have a substantial compliance offering. And finally, sustainability. So all of this you'll expect to be running based on Microsoft's commitments to global climate change, running off 100% renewable energy by 2025, being water positive and zero waste certifications by 2030, and having a net zero deforestation and new construction. And then there's wider goals that Microsoft as a company also have. To give you a bit of a perspective, I suppose you can learn more about our data centers online. There is a virtual tour. In COVID times, physical tours are a bit more difficult to do, even though they were conducted in the past. But on the right-hand side of the slide, you'll see a picture of, in the inset, what one of the original Azure regions look like in terms of a number of data centers in that region. And then literally 2 years later, you'll see the expanded area. So this is also gives you an idea of the scope and the scale and the growth that public cloud, and in particular Microsoft Azure, is growing at. So it's not just a data center or not just machines in a particular place. Azure has actually over 1,000 products at this stage, 20 different types of services that you could have, from compute to networking to security, from infrastructure as a service, IaaS, to platform as a service, to software as a service. So you can get a machine, you can get a database, you can get a machine learning service if you like. And open source is a key component of what we do. I myself have built my career Linux and open source, and for 5 years I've been showing this slide that shows the old world of Microsoft being not friendly to open source. It is no longer true. It hasn't been true for a long time, and I myself even deal almost exclusively doing Linux, and Linux operating system is the basis for HPC and supercomputing for people's compute. We do Windows as well, of course. And in terms of the HPC ecosystem, this translates also to working very closely not just with customers, but with vendors, with partners, and the whole ecosystem to enable HPC and supercomputing on the cloud. So that's the application level, the partner level, we work extremely closely with AMD, and we're very proud of having the EPYC processors available, GPUs, CPUs, and that are forming the basis of real supercomputing for a decent price, performance, and enabling customers to do more. What's particular about Azure as well for HPC is that we have designed and built this specifically for HPC. So we've not just chosen machines that we thought would work for HPC jobs. We have spent a number of years designing HPC generations. We're in the 4th or 5th generation of our H series machines, and there's been a lot of learnings along the way. And in particular, the HB machines that feature the AMD EPYC processors have really provided the best cost performance that you'll see for many different types of simulations. So this is a real differentiator for us. We are designing HPC systems, and we're doing this together with our partners. We provide InfiniBand networking, which is also unique in public cloud services. So you can have a real low latency, 200 gig a second InfiniBand experience currently to date. This is also coupled with storage solutions. So not only build your own high performance parallel file systems, but use services from NetApp, from Cray. We have a unique relationship with Cray HP in order to provide Cray supercomputers in the cloud. You might have seen that in relation to the UK Met Office deal lately. And in terms of workload orchestration, we have unique tools like CycleCloud and Batch to scale all of this up automatically up and down as you might need, coupled together with increasing use of artificial intelligence and machine learning services, and you really have a powerful combination for doing traditional HPC. And that's also what I would illustrate in this slide, because on the left-hand side, you can see a picture of what a regular Linux cluster or a Windows cluster might look like in the cloud, having a head node that you log on to and some execute nodes doing some work, to a full embedded scenario where this cluster or multiple clusters running simulations are part of a wider workflow. So such is the case in autonomous driving, where you'll see data being generated by cars, ingested into the cloud, there's some processing on it, and there's some simulation about what would happen if the cars were to drive in different scenarios like snow or rain. Machine learning models are built on that and put back into the car. And HPC is embedded in the cloud as part of that larger workflow and enables that workflow. So that's what simulation and HPC and supercomputing in the cloud are enabling us to do. So why are people using it? I've just alluded to some of that there, but I mean, HPC, of course, as you know, and is driving innovation. Access to this type of simulation is enabling more people to do simulation. So to have this fast computation power at the touch of a finger, just of a piece of code, is really unique, rather than waiting months lead time for machines and equipment to come in for you to operate it yourself. Really, you can think about the business problem, the application, the simulation that you're really doing. So there's fantastic insights to be had by doing this, and you save time and you save money by doing it. So that is fueling more HPC growth, and then the cloud advantage allows you to do all of that HPC in the cloud if you really like, but also to augment your existing capability. So where you've made an investment already in a supercomputer and you need to cope with the spikes, somebody lands some data on your desk that needs to get processed, or you have some simulation that you might not be able to do, you want to move some small jobs off to the cloud and keep the big ones on your on-premise, whatever it is around your strategy, the cloud can kind of fit into that. And we have customers at all spaces of that. The industries we focus on and the scenarios you'll see, including automotive, which I've mentioned an example, financial services, energy, all of these are industries which we work in, and our team provides depth expertise about the simulations in each of these types of industries. So I myself have a background in energy, oil and gas, bioinformatics, and I know a lot about the science and the simulations in that space. So you'll see also that these are typical HPC scenarios, and we have customer references for these. So some examples around in life sciences, where you might do not just genomics, but clinical trial simulations, drug discoveries. These are real scenarios that customers are working with now and that are doing HPC supercomputing in the cloud with now. Workstations is a very common one as well, because in order to do a simulation, you might need a remote desktop or a workstation, a powerful one to interact with a model. And people would assume that you have to send data up to the cloud and send it back to your workstation. No, you can do the workstations in the cloud as well. And this enables the full workflow. And you'll hear more about doing this with the AMD NVV4 series later on, which really has given us a new capability to do different sizes of these workstations for different types of power users. So it really has enabled a lot in COVID times as well to be able to do that. And using the AMD EPYC in the NVV4 machine type that we have in Azure, you can see some of the examples of the software vendors that we have close relationships together with AMD and have really optimized this type of software to enable these scientific workflows for users. So it is really allowing us to scale up and down with different sizes of workstations, as well as the HB machines, which I'll talk about shortly. So in terms of the breakthroughs as well, you'll see the technology is always progressing, particularly in the cloud too, and AMD have been critical to that too. So a number of years ago, when we announced one of the generations of our HB series machines with AMD EPYC, a number of months later after the announcement, that was when customers could use the machines. In our most recent announcement earlier this year, HBV3, the machines were available on the announced date. And we're very proud of that relationship with AMD to be able to deliver and improve upon the delivery of that so that customers can get immediate access to using the AMD EPYC Milan processors, in this case, the first place that you could get them. There's plenty of details about how different applications will scale at different sizes of MPI as well, but you can safely assume that we're going up to 80,000 cores, 90,000 cores in single simulations, which is really true HPC and supercomputing at this kind of scale. Who is using it? There is a short video that I think probably won't work. But to give you an example, more than 95% of the Fortune 500 customers choose Azure. Many of these are doing HPC, including the logos that you see on the screen. And then, of course, some of the names that we know well across the ecosystem in terms of vendors, software vendors, partners, hardware vendors that we, again, are working closely with to enable true HPC. So there is a nice video that probably won't play here. It's about Duke University using HPC.
Started very early on in the entire pandemic. You heard in the news every day that there was a need for more ventilators. One of our colleagues wanted to create a device to help improve ventilator capacity in splitting ventilators between two patients. To do that, we needed to run hundreds of millions of simulations that in total required almost 1 million compute hours. We applied to the COVID-19 HPC consortium, and then they paired us with Microsoft AI for Health. They pulled in experts and they figured out everything we needed for the infrastructure while letting us focus on the science. By Monday morning, we had completed 800,000 compute hours and finished the entire job within 1 week of submitting the application. We used the Azure Cycle Cloud platform because it allowed for dynamic, resilient computing. We were able to get 800,000 compute hours over a weekend. It was pretty amazing to be able to submit for FDA approval less than a week and a half after requesting the compute time. We hope that having a device like this will allow physicians to have a safer way for making these difficult decisions.
So that it's great that video played. It's always best to hear the customer's voice, and that's 800,000 CPU hours over a weekend that they were able to obtain, orchestrated by Cycle Cloud using a traditional Linux cluster, running MATLAB, and also using AMD EPYC CPUs. So they had 200 of the HB120 machines available for those simulations. There's plenty more customer stories on customers.microsoft.com. I'm sure you can find one for some of the use cases in the industries that you might be interested in. A little bit on how to use this now and what exactly it might be. So there's a number of customers that take different parts of this journey. The easiest thing to do is you could already lift and shift your application to virtual machines running these HPC virtual machines in the cloud. If it's a Linux application, a Windows application, why not simply copy it over, spin up a Linux machine or a few Linux machines and run it? You might be already surprised that it runs. Of course, you can start to tailor and customize and optimize for the cloud. So that usually is the first step, and people can already get some benefit from doing that. But maybe you want to combine it with data syncing from on-premise, bursting from a particular scheduling solution, or maybe building your own cloud-native applications. So where you can actually leverage services like Azure Batch, and you don't need to have a scheduler embedded. You can pull data from different places. The customers are doing solutions at all of these cases. The resource stack features right away, as I've mentioned, from our H-series machines featuring AMD EPYC CPUs to the storage solutions, the networking with InfiniBand, and orchestration to be able to do this automatically. So tools like Azure Batch, Cycle Cloud, virtual machine scale sets will allow you to create these HPC supercomputing clusters on the fly. There are a number of different sizes. So this is the unique thing. We can really size a solution and a cluster and a supercomputer, not just for a particular user group, but for an individual job. And different sizes of machines will really allow us to do that and give us flexibility. And with the AMD EPYC Milan processors recently released, our HBV3 machine, we have a huge capability to do that. Things have been simplified in this, including the reduction of the number of NUMA domains, which also makes it simpler to use the machine in some ways. This machine was available on the launch date. It's already producing lots of benefits in terms of cost performance for our customers, and different sizes of this machine really tailor it to the different type of workflow. So if you're restricted to 32 cores for an ANSYS license, you don't have to use all 120 cores of this machine, and you can really get access to a particular size of memory bandwidth to enable to do the simulation faster. So the faster you can do the simulation, the cheaper it's also going to be for you. In terms of the visualization and the compute capabilities around GPUs, these are also available. The NV series for visualization is the one that we focus on for workstations, and where we're very proud and happy to have the AMD EPYC processors in these machines also for different sizes, which gives us a capability to spin up a machine for a basic Linux or Windows desktop to a high-end workstation that really needs interactive power. There's plenty of storage solutions that we've mentioned before, with details about for a small solution size, a large-scale simulation, multi-petabyte scale simulation with Cray Cluster Store, for example, or caching on-premise with HPC Cache. And you can always build your own parallel file system or simply attach disks to a machine and share it out for your simulation, and you can do this on the fly. Some of the solutions we have to do this are including Azure Batch on the left-hand side, which includes a scheduler and a resource manager. So you just send jobs to Azure Batch, it'll spin up the machines you need, shut them off when you don't need them, and it'll schedule the jobs on those machines too. Azure Cycle Cloud actually doesn't have its own scheduler, but works with the industry standard schedulers like Slurm, PBS, LSF, Grid Engine, any of these and more. You can just spin up a cluster with one of those. It looks exactly the same as you might have on-premise, and you can really do the same type of simulation as you're used to on-premise. Cycle Cloud also gives you a lovely interface and API to interact with it to do this automatically, to get insights about users that are using the system, adding monitoring as well, and from an IT perspective or a user perspective, giving you that additional management. So that's been a bit of a whirlwind tour about what Azure is and what Azure HPC is, who's using it, why they're using it, how to use it a little bit, and now for some next steps. So really how to get started. Microsoft has really been on a journey with HPC for a long time, but in the last number of years has really expanded. There are hundreds of us inside Microsoft focusing on HPC, working closely with vendors. There's people in sales, in support, in management, in engineering, in partnerships. We have a dedicated Azure HPC support team, so you can file tickets directly to that team with HPC professionals who know what you're talking about and will answer your questions for you. And if you're looking to get started with a project, my team, the Global Black Belt team, particularly can help, and we'd love to work together with you and with our partners in AMD as well to do this. So, Jay Caton from AMD, you can reach out to him. His email address is there, or you can reach out to me. My email address is there. We'll work together to help you optimize your solution, your workflow, and really show you the power of using these AMD EPYC CPUs in Azure, how quickly, how easy it can be. And there's plenty of also other resources that can get you started, get you going quickly. Something that you can think about is that if you have a compute job you already know how to do, why not try that in the cloud and see how quickly and easily you could do it? Or alternatively, if there's something you haven't been able to do on premise, why don't you think about using the cloud as a potential project for that? And once you just get started with a project, then that's how we learn. That's how we all learn. And maybe you'll be able to see then if this could really provide you the benefit that many of the other customers we're working with really does. So we're very grateful for our partnership with AMD. We're very grateful to have the opportunity to present to you. We'd love to hear from you, any questions and follow-ups. And back to you, Sharon. Thanks a lot for the time and the support here.